In this video, we will talk about the arc length. So, as you can see in this equation, this is pretty much all you need to know about the arc length. It is the integral of the square root of 1 plus the derivative of the function squared. So let me show you some arc length examples. So as you can see here, we have a function y equals to e to the power of x from 1 to 3. As you can see here, there's 1 and 3. So pretty much all we're going to do is deriving the function ex, and the derivative of ex is just going to be ex, but we're going to square that function that is already derived. So when you square e to the power of x, you're going to be left with e2x. Since the x is already in the exponent, we're just kind of like multiplying by 2 to x. And once we got our derivative that is squared, we can just plug it back. So the a would be 1, the b would be 3, and the square root of 1 plus e to the power of 2x dx. And this is like the basics of what you need to know, or a simple visual of what it's going to look like without it being integrated. So let's take a look at this example. So let's say you're trying to find the arc length of this function. So our first step would be, find the derivative of y. So we can bring this exponent here to the front. 3 divided by 2 minus 2 divided by 2 will be 1 over 2, because we're literally dividing by or minusing by 2. We'll be left with x to the power of 1/2. And we can square root this or square this, and we can square this. So we will be left with x to 2 over 2, which would be just x. So the derivative would be just y equals to x. And now our second step would be finding the arc length. So they gave us the limits. So it's from 0 to 2. And square root, we put in our squared derivative into this slot. And we can use u substitution. So this will be much more easier. So that will be just dx, because it will just be derived to 1. And when we do that, we have from 0 to 2, u, we're substituting u now, and this would be u to the power of 1/2. Now we have to integrate it, so we were adding by 1, so this would be 2 over 2, because we need to find the same denominator. So u would be equal to 3 over 2 over 3 over 2 multiplied by the reciprocal, so this would be times 2 over 3, and we would have 2 over 3 u to the power of 3 over 2 as the final integral. And now we have to put in our values from 0 to 2. Let's move on to step 3. 2 over 3 u to the power of 3 over 2 from 0 to 2. We have to plug in our limits to u. So u was originally 1 plus x. Now we plug in these two. So for 0, 1 plus 0 will be 1. And we plug in 2 for x. 1 plus 2 equals 3. So our new limits would be 1 and 3. Now it's time to plug it in. So you can take out the 2 over 3 to make it easier. So plug in 3 for u. So this would be that, and plug in 1. And now we have to do the rest. So 3 to the power of 3 is 27. 27 squared. It's going to be that minus 1. So 27 squared, we can simplify this further. So 3 times 9. 9 is equal, has the factor of 2 3s. So we can use 1 3 and we can leave the 3 out. So this would be just 3 square root of 3, and this would just be minus 1. We can multiply or distribute. So 2 over 3 times 3 square root of 3 would be 6 over 3, but we can cancel out the 3 here. So this would just be 2 square root of 3, and we can multiply 2 over 3 times negative 1. So it will be minus 2 over 3, and this is our final answer for the arc length.